Myself, Ram Prasad, working as assistant professor in Department of Mechanical Engineering in MBR College of Engineering and Technology. Today, we will discuss about methods for families. So, in our previous lecture, we will discuss about what is group technology and what is family. So, introduction that one our previous topic one. So, today we will discuss about methods for families. So see here benefits of group technology. So in this lecture we are learning about group technology. Group technology is nothing but where the similar parts are identified and grouped together is known as the group technology. So in group technology, what is the benefits of group technology means? So it affects all area of a company, including engineering field. It included equipment specifications, facilities planning, process planning, production control, quality control, tool design, purchasing, services. So these are the benefits for the group technology. Next one we can see methods for group technology. So methods for family. There are three general methods for solving families grouping one. So all are three are time consuming and involving the analysis of much of data by properly trained persons. So the three methods are, so in this one we have the three methods of families. The first one is visual inspection one, second one is path classifications and coding one, third one is production flow analysis one. So these three methods are very important for the families one. So the three general methods for solving the path families grouping one. So these three methods are used to grouping the path families one. So all three are time consuming one and involving the analysis of much of data by properly trained persons. So that is the main concept here, Amma. So there are three methods. The first one is visual inspection, path classifications and coding one. Third one is production flow analysis one. So see here, first one is visual inspection method. The visual inspection method is the least sophisticated and least expensive method one. So it is the one of the least sophisticated and least expensive method, this one. So it involves the classifications of parts into families. So number of parts into it is converted into the families by the looking at the either physical part. So looking at the either physical parts or their photographs and arranging them into the group having similar features one. So this one we can call as visual inspection method one. So in this visual inspection methods one, what they are, how they are arranged means looking at either the physical parts or photographs and arranging them into groups one. So parts and photographs they are arranging into the groups having similar features one. So those have the similar features in the physical parts and photographs. It is grouping the each other one. So this one we can call as visual inspection method one. First one is, so second one is we can observe part classifications and coding methods. So parts classifications, so parts it will be classified and give the coding one. So that is the meaning about this one, path classifications and coding methods one. So in path classifications and codings, similarities among paths are identified. So and these similarities are related in a coding system. So first one is the similarities parts are identified and the similarities are related into the coding system. So the similar parties are identified and due to the coding one. So that one we can call as path classifications and coding method one. So see here two categories of path similarities can be discussed below. See here, first one is design attributes. Second one is manufacturing attributes. First one is design attributes. Second one is manufacturing attributes. So which conquered with the parts characteristics such as geometry, size, and material one. So which conquered with the parts characteristics. So in the design attributes one, so it is conquered with the path characteristics such as geometry, size, and material one. So they, some example they give the geometric size and material is nothing but basic external and internal shapes one. So we have the basics one. So it is a design attribute. In design attribute, what we consider means internal and external shapes one, rotational or rectangular shape one. So L by D ratio one, accept ratio one, dimensional and tolerance one. So these are the total one is go for design attributes one. In design attributes, we are considered this type of functions one. So next one is manufacturing attributes. So in manufacturing attributes, which consider the sequence of processing steps. So in this manufacturing attributes one, so they consider the sequence of processing steps required to make a part one. Some example one required to make a part one must and should we are consider the sequence of processing steps one. So what are the sequence of processing steps to require to make a parts means see here major process one, minor operations. So major process on the first one, second one is minor operation one, next one is operation sequence, dimensions, so surface finish, mission tool, and production cycle time. So these are the manufacturing attributes. So these are the manufacturing attributes one. So in manufacturing attributes one, we are considered as major process, minor operation, operation sequence, dimensions, surface finish, mission tool, production cycle, time one. So these are the manufacturing attributes. So when your design is completed, automatically we can give the manufacturing attributes, give the coding one, particular operations one. So with the major process one, minor operations will give the coding one, operation sequence also give the step by step one. So dimensions, surface finish, mission tools, production cycle time. So these are the manufacturing attributes. So there are three basic code structures used in group technology generally. So it is the path classifications. So next one, generally in group technology we have the three coding structures. The first one is monocode or hierarchical code one. First one is monocode or hierarchical code. Second one is polycode or attributes. Third one is hybrid or mixed code one. So these are the three types of codes used in group technology. The first one is monocode or hierarchical code. So in which interpretation of each successive symbol depending on the value of the processing symbol one. So in which the interpretation of the each successive symbol, so each successive symbol depends on the value of the processing symbol one. So value of the processing symbol one is depending on some example to make here this part one. So we give the some codes one. See here. So it is a part. So we want to manufacture this part one. How can we manufacture? Means they give the symbol one. See here. So they give some symbols. So some example A. If A and B we have A and B. A if rotational one, B if it is non-rotational. So if this part is we go for rotational one, we go for A1. So it is not considered for rotational one, we can go for irrotational, go for B1. So in a rotational one, we have some classification. See here again A onwards we can go for 2 1 1 2. We have the 1 1. So if the round with the deviation 1 A minus 1, that is the first one. So if round one, second one is if round, so it's enough. If round one, it's okay. So if round with the deviation, we can go for A minus 1. So round with the deviation 1, again we have the 2 1. See here, if gear, so if gear we can choose as A minus 1 minus 1. So see here, if gear 1, so it is a gear. So that's why A minus 1 minus 1. So it is the 2 if non-regular deviation 1. So it is a non-regular deviation 1 2 onwards. So it is again we can choose for A minus 1 minus 1. Why A minus 1? Why minus? If round with the deviation this one, minus if gear 1, round with the deviation and gear 1 this one. So again if gear 1 we have the 2 1. See here. So if A minus 1 minus B is if external gear. If it is external gear, we can choose this code one. So if it internal gear, we can choose this one. So it is the total monocode or hierarchical coding one. So it is by using this code to successfully to achieve one part one or to manufacture one part. The part is nothing but gear. So by using these symbols, so by using these functions, we manufacture in polycode one gear one. So this is the gear one. So it is the monocode or we can call as hierarchical code one. So how they are manufactured this part means by using this codes one automatically you can manufacture this gears one. So see here another code one, polycode or attribute code. Polycode or attribute code one. So in which the interpretation of each symbol in sequence is always the same one. So in which the interpretation of each symbol in sequence is always the same one. So each symbol is always the same sequence one. So it does not depending on the value of the preceding symbol one. So in this one, polycode or active root code one. So it does not depending on the value of the preceding symbol one. So it is not depending on the value of the symbol one. So in this particularly polycode or active root code one. So see here examples of the polycode or active root code one. So they use the code value 1, 2, 3, 4, 5, 6, 7, 8, 1. 8 1. So 8 1 they are given one. So the first one is code value, this one. So first one is one material one. So some example one, how can it is a design attributes. So it is the design attributes one. See here, first one is you can take the material one. So it's 2 1 material form one. So material form one. So third one is material property one. Material property one. Fourth one is material property one. Third one. Fourth one is bending method one. Fifth one is tolerance one. Sixth one is surface finish one. Seventh one is a test method. Eighth one is special requirements one. So it is the poly code by using these symbols one. So by using these symbols one, so we want to manufacture these parts one. So it does not depend on value or processing symbol. Symbol is not required. It use the code one. So these are the codes one: 1, 2, 3, 4, 5, 6, 7, 8, 1. So digital value depending on the choosing the alphabet code one. So digital value it is depending on the alphabets code one. So it is the code sum of 1, 2, 3, 4, 5, 6, 7, 8, 1. The first one is material one, second one is material form one, third one is material property one, fourth one is bending method one, fifth one is tolerance one, sixth one is surface finish one, test method one, special requirements one. These codes, when using this code and these codes are used for manufacturing one. So it is the polycode and active roots code one. So next one we can see hybrid or and decision code one. Decision hybrid or we can call as decision code one. So see here in a hybrid or decision code one, construction to constructions to combine the best features of monocode and polycode. So in construction to combine to get the best features to combine with monocode and polycode by using monocode, that one, and is polycode, both are we are combining one and get the best features one. So best examples are hybrid code is the opt-based code one. So in hybrid code the best example is opt-based coding system and classification systems. So see here it is a more hybrid code or decision code one. It is a polycode. It is a polycode. This is a monocode. So the combination of these two code to get the best features. So that is the in construction one. The construction to combine the best features of monocode and polycode is known as the hybrid or decision code one. So it is a polycode. It is polycode. We are combining these two ones. So we are getting the hybrid or decision code one. So and we are getting also best features by combining these two codes. So best features we are getting on manufacturing one. So it is called as the this hybrid or decision code one. So next one is we can see Optis coding system. Optis coding system. So see here Optis coding system is one of the example for the hybrid or decision code one. So see here, so it is the sequence one, Optis coding system, digit one, part classes one. So it is the parts classes one, amma. So it is a parts classes. Part classes is nothing but we can take the dimensions, so each and everything. So it is a rotational or a rotational one. So it is with the deviation or without deviation one. So total the total process is going on digit one part classes. So comes to the digit two main shapes one. So shape is nothing but main shapes. So external or internal, whatever it may be. So the second one is the main shape one. Comes to third one is rotational machining one. So rotational. So internal and external one. So it is the rotational code one, digit three. Digit four is nothing but plane surface machining one. So machining one, digit five is additional holes, teeth and forming one. So additional holes and teeth, forming one, digit five. Comes to the last one is supplementary code. So it is a supplementary code one. So it is a manufacturing step by step one. So these codes are used to manufacture gears and other parts also. So it is the most procedure amount digit 1, digit 2, digit 3, digit 4, digit 5. So it is a supplementary code digit sum 6781. So see here, the first one is digit 1. So in this one symbol, so see here 0 to 1, 0, 1, 2, 3, 4, 5 we have. So this 1 to up onward, 1 to 5 onwards we can call as the design active roots. So 1 to 5 it is a design active roots. So the total this 5 1 we can go for design one. So 6, 7, 8, 9 it is a manufacturing active roots. So it is a manufacturing one. So A, B, C, D. So it is a production operation types and sequence one. So see here A, B, C, D, A, B, C, D. We have the A, B, C, D. So A, B, C, D is a production operation type one and sequence one. So it is the basic sum. See here, first of all, you can go for digit one. So the first one is 1 to 5. Design attributes. Design attributes, it is a rotational one. So it is a rotational one. So 6 to 9 onwards it is a non-rotational one, it is a manufacturing attributes one. So we can go for manufacturing attributes one. See here, so first of all we can choose 1 2 0 1 2 3. So it is external shape element one, external shape element one, that is the main shape one. So we are getting main shape, we can go for rotational one. So internal shape element one, it is the external shape main shape one. After we can go for internal shapes. So see here a rotational machining one digit 3. So we can go for, after we are getting external and internal elements, shape of the elements, we can go for machining one, machining of the plane surface one. So we can go for digit 4 1. So often we can go for machining is completed, external internal elements is completed, and machining also completed. We can go for other holes and teeth work. So in this machining operation one, we can give to the hole and teeth also. We can this one is completed, holes and teeth also completed. We can go for decisions. So is the 6 1. So next one is go for, you can go for 7 1 material. So dimensions, material. Next one is original shape for materials one. So we're getting 8 1 onwards. We are getting the original shapes for material one. 9 1 is accuracy one. So what is the step by step about the digit one? So digit one for design active roots. So design active roots we are taking 0 to 3 1. So our step by step operation is one. So the first one is 0 0 1 2 0 1 2 we are taking. So in this one L by D less than or equal to 0 0.5, 0 0.5 less than L by T less than 3 1. So L by D greater than equal to 3 1. So 0 0 1 2, this is the step by step operation. Some example one, in this one we can choose for 3 and 4 1. 3 and 4 1. See here 3 and 4 1 we can getting. So with the deviation one, so with the deviation L by T less than or equal to 2, with the deviation greater than 2 1. So we are getting these two parts one, 3 and 4 1. So it is the main shape one. So we are getting these two one, 3 and 4 1. We are getting main shape one. So main shape onwards we go for rotational one, rotational machining one. So often we are getting for machining of plane surface one. Often we are getting other holes, teeth and forming one. Often we go for dimensions. Often we go for material one. So original shape of the material one and the accuracy we are getting. So it is the 3 by 4 operations one. So in design attributes comes to the main manufacturing attributes, it is a non-rotational one. So go see here we are taking 6 7 8, 6 7 8 we are taking one. So the first one is main shape, these 3 1 6 7 8 1 we are choosing one. So digit 1 onwards. So A by C less than equal to 3, A by C greater than equal to 4 1. So A by B greater than 3, so A by 3 less than or equal to 3, A by C greater than equal to 4 1. So it is the non-rotational one, it is the production operation type one or sequence one. So production operation types, or we can call as the symbols A B C D, sequence one. So see here it is the sequence one, we are getting main shape one, main shape one, we are getting digit 2 onwards. So see here digit 3 onwards what we are getting means main hole, main bore and a rotating machining one. Next one digit 4 1 machining of plane surfaces one. So next one is we go for digit 5 onwards, other holes, teeth and forming one. So after then we go for dimensions. So holes is completed, so we go for dimensions. After then dimensions onwards we transfer to material onwards, we go for original shape of the material one. After that finally we are getting the accuracy of the material. So it is the step by step operations for the Optis coding system. Optis coding system. H. Opti University as Aachen in Germany. Germany is introduced this Optis coding system. So it is the step by step one. So next one is we can observe production flow analysis one. This topic one. So it is the last topic for the uh, path families. So path families generally it is classified into three types. See here. So path families we are getting the three one. The first one is visual inspection is completed. Path classifications and coding system. The second one. Third one is production flow analysis one. In path classifications and coding system, we have the three one. So first one is polycode. So monocode, polycode, monocode, a hybrid code, and Optis coding system. Optis coding system is the example for the hybrid or decision code one. So see here, production flow analysis one, PFA. Production flow analysis is the method for identifying the path families. So in production flow analysis, what happening means in path families. In path families, what we are doing, the path families we are grouping. It is gathering the number of parts and gathering into the one family one. So number of parts it is gathering and creating one family one. So that is called as the path family one. Comes to here production flow analysis one. Production flow analysis (PF) is a method for identifying the path families one. So it is identify the path families. In path families, the number of parts are identified and grouped together. That one we can give the name to the path family. So in production flow analysis one, it is identify the path families one and assured with machining grouping one. So it is identify the path families and it is assured with machine grouping one that uses the information contained on the process plan one rather than on path drawing one. So this one we can call as the production flow analysis one. So steps involved in PA, production flow analysis one. So how they are identify the path families means they have the one steps one. Based on these steps one, they identify the path families one. So first one is data collection one. Second one is sortation of process routings one. Third one is preparation of FPA chart. Fifth one is cluster analysis one. So first one is data collection. So data collection, the minimum data needed in the analysis. So must and should in data collection one, minimum data is needed one and path numbers and operation sequence which is obtained from the process plan one. So it is called as the data collection one. To collect the data must and should need the analysis one. Minimum data is needed one. So and the path number and the operation sequence it is needed. After then only so it collect the data one. So next one is sortation of process plan one. So in sortation of process plan one, see here we are collecting the data and implement the plan one. So implement the plan one. How we are implementing the plan means see here a sortation procedure used to group parts one with identical process plans one. So here we are collecting the data. So collecting the data onwards it is identical process plan. We use the identical process plan one. So next one is FPA chart. So we are collecting the data and start the process planning one. So the total these two one they are give to the one chart one chart final one. The final these two data they are showing the this chart one PFA chart. The process used for each group and then display in the PFA chart as shown in below one. So each group are displayed. So the process used to each group it is used and then display in the PFA chart as shown in below one. So next one is clustering analysis one. In clustering analysis one, from the pattern of the data in the FPA chart one. So from the pattern of the data in the FPA chart one, related grouping one are identified and rearranged into a new pattern one that brings together in groups one with similar mission sequence one. So this one we can call as the clustering analysis one. In clustering analysis one, what they are doing means see here pattern of the data in FPA chart related grouping one. In FPA chart related grouping one are identified. Related means same grouping one. Some example one in file folder 1 and 2 we have. So same folder what happening on original folder is they will not give the one but same folder we have the another one, so we give to the folder 1. So this one is again we can copy the folder is 2 1. So example one we are ఇప్పుడు మనం డేటాను సేవ్ చేస్తున్నాం folder create చేసి సేవ్ చేసాం. సేమ్ ఫోల్డర్ మళ్ళీ కాపీ పేస్ట్ చేసుకుంటే మళ్ళీ అవుతుంది న్యూ ఫోల్డర్ 1 వస్తుంది. సో మళ్ళీ న్యూ ఫోల్డర్ 1 మళ్ళీ కాపీ పేస్ట్ చేస్తే న్యూ ఫోల్డర్ 2 వస్తుంది. మళ్ళీ న్యూ ఫోల్డర్ 2 ని కాపీ పేస్ట్ చేస్తే 3 వస్తుంది. సో అలాగా ఐడెంటిఫై చేస్తామమ్మా. ఎక్కడంటే చూడండి అమ్మా, పిఎఫ్ఏ చార్ట్ రిలేటెడ్ గ్రూపింగ్ 1 ఆర్ ఐడెంటిఫైడ్ అండ్ రీఅరేంజ్డ్ ఇంటూ న్యూ ప్యాటర్న్ 1. సో సో ఐడెంటిఫై ఎలా చేస్తామో సేమ్ ఉన్న దాన్ని ఏం చేస్తారంటే ఐడెంటిఫై చేసి మళ్ళీ న్యూ గ్రూప్ క్రియేట్ చేస్తారు అనమాట. అంటే 1, 2, 3ని గ్యాదర్ చేసేసి మళ్ళీ న్యూగా ఒక సింబల్ ఏదో ఒకటి ఇచ్చేసి సేవ్ చేసుకుంటా ఉంటుంది. దట్ వన్ వీ కెన్ కాల్ as క్లస్టరింగ్ అనాలిసిస్ అంటారు. రీఅరేంజ్డ్ ఇంటూ న్యూ ప్యాటర్న్ that brings together groups with a similar missioning sequence one. So this one we can call as clustering analysis one. This is the production flow analysis one. Production flow analysis one. It is one of the analysis method in the group technology one. By using how can they analysis this production flow analysis means we have the step by step one. These 4 steps. By using these 4 steps to analysis the production one. That one we can call as production flow analysis one. So next one is we can see production flow analysis one advantages to reduce the flow distance one. The first point one, better suited to JIT and full manufacturing ones, as the overall flow is much straighter one. So it is better suitable to the JIT and full manufacturing as the overall flow in the much straighter one. That is a better suitable PFA. So next one is simple and easy to implement one. So it is implemented production flow analysis one. So simple and easy to implementation one. So experiences, a lot of reaches. So a lot of reaches and background and support software one. So it is one of the analysis is nothing but, so a lot of reaches is important one. Why? Because we can analyze, how can we analyze a lot of reaches onwards, the analysis is done properly one. So the research is not in proper way, the analysis is, we can see the some drawbacks on the analysis one. So that is the main here. Experience is nothing but lot of research and background and support software one. So these are the PFA advantages one. PFA advantages, production flow analysis advantages one. So next one, these are the methods in path families one. Next one we can see new topic, computer aided process planning one. CAPP, computer aided process planning one. So it is the introduction about the CAPP. Process planning is considered with the determining the sequence of individual manufacturing operations, so needed to produce a given path. So this one we can call as CAPP. So process planning is concurred with determining the sequence of individual manufacturing operations. So it is planning. So computer aided process planning one. So in computer, computer is involved in the process planning one. So how they are planning means it is determining the sequence of individual manufacturing operations. So first one, they are determining the sequence of individual manufacturing operations need to produce a given part one. So we give one part to the ఇండస్ట్రీస్ వన్, ఆర్ నా రిక్వైర్మెంట్ బేస్ చేసుకుని ఒక పార్ట్ ని ఇచ్చానమ్మా. ఎవరికి? నా రిక్వైర్మెంట్ బేస్ చేసుకుని ఒక మోడల్ మ్యానుఫ్యాక్చరింగ్ చేయమని ఇండస్ట్రీస్ కి ఇచ్చాము. ఇండస్ట్రీస్ కి ఇచ్చినప్పుడు సిఏపిబి ఏం చేస్తుందంటే, సో ఇది డిటర్మైన్ చేసుకుంటుంది సీక్వెన్స్ ఆఫ్ ఇండివిజువల్ మ్యానుఫ్యాక్చరింగ్ ఆపరేషన్స్. సో ఇండివిజువల్ గా, సో మ్యానుఫ్యాక్చరింగ్ ఆపరేషన్ సపరేట్ గా ప్లాన్ చేసుకుంటా ఉంటుంది. అంటే స్టెప్ బై స్టెప్ అనేది ఇండివిజువల్ గా ఆపరేషన్స్ ఏం చేస్తుందంటే సపరేట్ చేస్తూ ఉంటుంది. ఫస్ట్ స్టెప్, సెకండ్, థర్డ్, ఫోర్త్ వన్. సో ఇలా ఇండివిజువల్ మ్యానుఫ్యాక్చరింగ్ ఆపరేషన్ చేసుకొని నీడ్ టు ప్రొడ్యూస్ ఏ గివెన్ పార్ట్ వన్. మనం ఏదైతే పార్ట్ ఇస్తామో దాన్ని సక్సెస్ఫుల్ గా కంప్లీట్ చేస్తుంది ఆ ప్రొడక్ట్ వన్. సో దిస్ వన్ వీ కెన్ కాల్ as the computer aided process planning one. So in determining the sequence of individual manufacturing operations is known as the computer aided process planning one. Need to produce a given part or product is known as the CAPP one. So the resulting operation is sequence is documented on the form referred to as a root sheet one. సో ఇది సీక్వెన్స్ ఆఫ్ ఆపరేషన్స్ ఎలా ఉంటుంది అమ్మ చూడండి అమ్మా. సీక్వెన్స్ ఆఫ్ ఆపరేషన్ అనేది సో డాక్యుమెంటెడ్ ఆన్ ది ఫార్మ్ ఆఫ్ రిఫర్డ్ టు యాజ్ ఏ రూట్ షీట్ వన్. సో ఇప్పుడు ఏం చేస్తుంది సిఏపిపి, సో మ్యానుఫ్యాక్చరింగ్ చేయాలంటే సీక్వెన్స్ లో ప్లాన్ చేసుకుంటుంది. ఆ సీక్వెన్స్ ఆఫ్ ప్లానింగ్ అనేది డాక్యుమెంట్ రూపంలో ఉంటుంది. సో ఈ డాక్యుమెంట్ ఈస్ రెఫర్ టు యాజ్ రూట్ షీట్ వన్. సో ఈ డాక్యుమెంట్ అనేది ఏమంటారంటే ఇట్ ఈస్ రిఫర్ టు యాజ్ రూట్ షీట్. ఈ రూట్ షీట్ లో ఏం ఉంటుందంటే మనం ఏదైతే సీక్వెన్స్ ఆఫ్ ఆపరేషన్ ప్లాన్ చేసో ఆపరేషన్ ప్లానింగ్ అనేది రూట్ షీట్ లో స్టోర్ అయి ఉంటుంది. సో ద రూట్ షీట్ ఈజ్ ఏ listing of the production operation one. So see here, so root sheet is a listing of production operations. So here we are planning one. In sheet one, we are planning. When we open the sheet one, so listing of the production operation one. List we have 1, 2, 3, 4, 5. So list one. So first one is drilling, second one is milling one, third one is boring, fourth one is surface finishing one. So these operations we can see on root sheeting one. So and assisted with mission tools for a work pan or assembly one. So this one we can call as the computer aided process planning one. So it is the introduction about the CAPP one. CAPP, what we are doing, so it is planning the sequence of operation one. So sequence of individual manufacturing operations, it will be planning one. Individual operations 1, 2, 3, 4. So in NC1 we have the number of operations. So number of operations individually, it is planning one. After then planning, after then it is implementing one. So it is called as CAPPM. So it is the one today class one. So once again, I will revising the total topics one. See here. So first one is first comes to our topic one. So group technology. So yesterday previous lecture we will discuss about the introduction about the group technology, advantage of group technology, and we will discuss about path family. So comes to here, it is a group benefits of group technology. This one. So engineering one. Engineering field, it is benefit one, equipment specifications, facilities planning, process planning, production control, quality control, tool design, purchasing one, service one, this one. So methods for path families. So in path families is nothing but it is there are three general methods for path families. In path families one, we have the three methods one. The first one is visual inspection, path classifications, and production flow analysis one. What is the path family means? Number of parts are it is identified and grouped together. The group one give to the one family one. So in family one we have the three types of classification. The first one is visual, path classifications, production flow analysis one. This one. So next one is the visual inspection. This one. So it is the visual inspection ones based on the shapes. So it is the classifications of parts into families by looking at the physical parts or photographs. So physical parts are photographs are it is gathering and gathering into the path family one. So this one we can call as visual inspection method as amma. Physical parts కానీ photographs కానీ ఇది ఏం చేస్తుంది అంటే ఒక గ్రూప్ గా ఫామ్ చేసుకుంటా ఉంటది. సో ఇట్ ఈస్ ద ఫిజికల్ పార్ట్స్, ఇట్ ఈస్ ద ఫోటోగ్రాఫ్స్, రెండు ఏం చేస్తుంది ఒక ఫ్యామిలీగా క్రియేట్ చేస్తా ఉంటుంది. దిస్ వన్ వీ కెన్ కాల్ as విజువల్ ఇన్స్పెక్షన్ మెథడ్స్ అంటారమ్మా. నెక్స్ట్ వన్ ఈస్ పాత్ క్లాసిఫికేషన్స్ అండ్ కోడింగ్ సిస్టమ్. సో పాత్ క్లాసిఫికేషన్స్ అండ్ కోడింగ్ సిస్టమ్ ఏంటనమ్మా, పార్ట్స్ క్లాసిఫికేషన్ చేస్తుంది అండ్ కోడింగ్ ఇస్తుంది అనమాట. సో పాత్ క్లాసిఫికేషన్ అండ్ కోడింగ్ సిస్టమ్ లో మీకు టూ ఉంటాయి. పాత్ క్లాసిఫికేషన్స్, పార్ట్స్ క్లాసిఫికేషన్స్ వీ హావ్ ద డిజైన్ అట్రిబ్యూట్స్ వన్. సో పార్ట్స్ తెలియాలంటే అది ఇంటర్నల్, ఎక్స్టర్నల్ షేప్, రొటేషనల్, రిరోటేషన్, రెక్టాంగులర్, సో ఎల్బిఈడి రేషియో, యాక్సెప్ట్ రేషియో, డైమెన్షన్స్, టాలరెన్స్, ఇవన్నీ కూడా పాత్ క్లాసిఫికేషన్స్ అమ్మా. ఇవన్నీ పార్ట్స్ వచ్చేసి డిజైన్ అట్రిబ్యూట్స్ లో మనం డిజైన్ చేసుకుంటాం. నెక్స్ట్ వన్ ఈస్ మ్యానుఫ్యాక్చరింగ్ అట్రిబ్యూట్స్. మ్యానుఫ్యాక్చరింగ్ అట్రిబ్యూట్స్ లో ఏం చేస్తాం అంటే డిజైన్ చేసిన తర్వాత ఇది కోడింగ్ ఇస్తాం. సో మేజర్ ప్రాసెస్ వన్, మైనర్ ఆపరేషన్ సీక్వెన్స్ వన్, డైమెన్షన్, సర్ఫేస్ ఫినిష్, మిషన్ షూల్, ప్రొడక్షన్ ఫ్లో అనాలిసిస్ వన్ అమ్మా. సో ఇట్ ఈస్ ద పాత్ క్లాసిఫికేషన్ అండ్ కోడింగ్ సిస్టమ్స్ అమ్మా. సో దే ఆర్ త్రీ బేసిక్ స్ట్రక్చర్స్ వన్. Actually in group technology we have the three types of coding systems మనం డిస్కషన్ చేస్తున్నాం కాబట్టి group technology we have the three classifications. Now first one is monocode or hierarchical code, polycode, hybrid or mixed code one. So in first one is monocode one. So it is a monocode to manufacture one gear one. So it is a codes one. By using these codes to manufacture this gear one, step one. So next one is polycode one. So it is a polycode one. So how can we get product means, see here it is a step by step one, 1, 2, 3, 4, give the letters one. These letters onwards they are manufacturing one. So it is not depending on the value of the processing symbol amma. So it is the main concept for the polycode and attribute code. Next one is hybrid or decision code. The combination of polycode and monicode we are getting the hybrid code. It is a hybrid code we are combining it. So these two polycodes and monicode we are combining and we are getting the hybrid or decision code one. So best example for the hybrid code or decision code is nothing but Optis coding system. This is Optis coding system. So in this Optis coding system we are manufacturing, we are adding one. What we are adding? Polycode and monicode we are adding one. So after that we are getting the one perfect output we are getting one. So how we are getting the perfect output means these are the example ones. So these are polycode and monicode we are adding one and getting the final output one. This is the Optis coding system. Next one is production flow analysis one. In path families the third classification is nothing but production flow analysis one. So in production flow analysis means it is totally analysis in the total plant one. We have the big parts one. So small tools manufacturing industry one. In tool manufacturing industries one, they are analysis one, production flow analysis one. How much it is producing for a day, for 1 hour, for 3 hours, for week, for one year. How much production is running one. So the total production is it is analysis one. That one we can call as production flow analysis one. We have the steps. So these are the steps. By using these steps, and we can analysis the production flow analysis one. So is the steps one, 2, 3, 4, 1. So next one is PFA advantages. These are the advantages. One next one is the computer process planning. Thank you. It is the today class one. Tomorrow class we will discuss about so production flow analysis one.